Now we are going to draw the graph of a to the power of x when a is in between 1 and infinity. So I have actually showed you the graph when a was in between 0 and 1. Now we are going to draw the graph of the exponential function a to the power of x when a is equal to 1 in between the range of 1 and infinity. So we actually try to take a value. So the easiest value we can take is actually 2. So 2 to the power of x. So 2 to the power of x is basically if I have is doubling something, basically increasing something by 100%. So if I have one coin today and I want to double it into two, if I have one coin today and if I get another coin, then the actually the function of this it will be then 1, then 2. If then these two coins again divide to form another 2 coins, then 4, then 8. Basically, this is the exponential function of 2 to the power of x. I guess mitosis division works in this way. So this is a real life example of 2 to the power of x basically. So for that we are going to start with taking the values of x in the positive direction because I want to start with the positive direction of x. So basically that is the reason. So for 0, if x is equal to 0, we know that y will be equal to 1 because anything to the power of 0 is equal to 1. And similarly, if x is equal to 1, we will get the value of 2. Then we bring our calculator, or we can actually work without a calculator. So if x is equal to 2, we get that the value of y is 2 to the power of 2 or 2 square, that is equal to 4. So if x is equal to 3, we get 2 to the power of 3, that is 8. So in similar way, we see that as the value of x is increasing, we also find the value of y increasing also. So if we skip all the values and write infinity, so we will see that the value of y then become also equal to infinity. I forgot to write that y equals to 2 to the power x. So see, if x reaches to infinity, then y will reach infinity too. So if x tends to infinity, then y tends to reach infinity also. So now we try to find the values in the negative direction, that is if x is smaller than 0. So x, y, if x is equal to minus 1, we see that the value of y is 2 to the power of minus 1, that is half. So half. Similarly, minus 2 will be minus 1 by 4. Sorry, minus, it is not minus, it is 1 by 4. Similarly, if you take the value of x is equal to minus 3, sorry, I will erase mode on. So minus 3, we will get the value of 1 by 8, which is equal to 1 divided by 8. So it is equal to 0.125. This is equal to 0.25, and half is equal to 0.5. So we take minus 10. If we take minus 10, we get 2 to the power of minus 10. We get 9.764 into 10 to the power minus 4. So see, if x is decreasing, that is x is moving in the negative direction, the value of y is also decreasing and gradually becoming close to 0. That is, if x becomes minus infinity or very close to minus infinity, we will get the value of 0. So as you can see, these are the numbers we are going to work with to draw the graph. So for that, we first draw two lines. So here this is the x-axis, x, O, x prime, and y, O Y Y. So we start by plotting the numbers on the graph. So for that we have, if use a different ink. So if x is equal to 0, that is this point. If x is equal to 0, we have y equal to 1. So y equal to 1. Sorry. Sometimes working with a digital board is tough. So now it's a straight line. So we get the value of x equal to, when x is equal to 0, we get y equal to 1. So here let us assume this is 1. Then when x is equal to 1, we get the value of 2. So 2 can be somewhere here. I guess the plotting was not right. So okay, it's not a problem. We need to actually show the general characteristics of the graph. So actual spacing doesn't matter that much. So when x is equal to 3, it becomes 8. And when x becomes to infinity, it becomes to infinity. So I can draw it here or here. Both is correct. And now we have actually reached our limit. So we can draw any more. Points on the positive side of x-axis. So we're going to move on to the negative side. So if x is equal to minus 1, we get the value of 0.5. So it will be somewhere here. Minus 5. So x is equal to minus 2, we get 0.25. So it will be half of the previous point. Similarly, if x is equal to minus 3, we get 0.125, again half of the previous point. And if x is equal to minus 10, we get a point that is very close to 0 but not equal to 0. And x is equal to infinity, we will actually move to the this part out of the board, so we are not going to draw it. So if you can see that we have actually found a way or found a graph. So if I join these points, see what will happen. Sorry, the line wasn't that beautiful, so I'm going to try to draw it again. So starting from here, so basically this is the actual graph. This is how the graph of a to the power of x will look. So a to the power of x when a is in between 1 and infinity. If you remember the previous graph was like this. So this was somewhat the graph of a to the power of x when a was equal to a was in between 0 and 1 was somewhere moving to this point, that is the y-axis, and so let me draw this part and then this part. So this was when a to the power x where a was in between 0 and 1. Basically anything that is in between 0 and then 0.2, 0.5, 0.125, for every values of between 0 and 1, we get this parallel graph, and when a is equal to in between 1 and infinity, we get this waved graph. So with that, I have actually showed you the graph of a to the power of x. So we are going to move on to finding the value of, or finding the drawing the graph of log of x to the base